because dot product is a new concept, it's kind of important to know some of the things that work with the dot product. Like what are some things we can count on? A lot of the properties of dot product are very similar to normal numbers. So if you'll notice, some of these, like u dot v is the same as v dot u. That's the commutative property. You just flip things around. We've got the 0 vector times u is 0. That makes sense because, or dot u, that makes sense because anything times 0 is 0, so it kind of holds up in this case. This is like the distributive property, so is this. This one is the associative property, so those are all fairly straightforward. The only one that's really any different is this number 2 is one that we maybe haven't seen before. But it's u dot u is equal to the magnitude of u squared. So I just want to illustrate that with one example here. If we have the vector u as negative 815, we can actually find the magnitude of it by using this property. So that would be u dot u. If we do that here, we have negative 8 times negative 8 plus 15 times 15. It's just a definition of a dot product. Overall, that turns out to be 289. Now that doesn't mean a whole lot to us other than the fact that this property says if 289 is the dot product of these two, it's also equal to the magnitude of that vector squared. And if we've got the magnitude squared and we want to find the magnitude, we could take the square root of both sides. And the square root of 289 is a nice number. That's 17. And so that means that the plane magnitude is 17. So there are other ways to get the magnitudes, obviously, but this is just one way, one alternate way to get that magnitude, and it just kind of illustrates the property number 2 in this dot product list.